I would like to talk about the things I have been doing in teaching, and the context is that I teach calculus, mostly multivariable calculus, to engineers, and I would like to tell you about the experiments I was doing and the use I made of Wolfram Alpha and Mathematica, and the future that I see of using Mathematica online. So I'll start with the lowest level from the content. The discovery, at least for me, it was a discovery that I made this summer, and I would be happy to discuss with you but what you think about it, was that the way at least mechanical engineers are taught at the University of Tennessee is very different in certain aspects from the way mathematicians teach mathematics, in particular calculus. So I was going to Department of Mechanical Engineering, and I was looking at a particular course on machine design, and they teach those 4-bar linkages. But first of all, I noticed that the content is very much in line with what I teach in calculus. If you look at those chapter names, position analysis, velocity analysis, acceleration analysis, you can immediately see the relation to the multivariable calculus when you introduce a function to describe position of a point, then you differentiate a function to find velocity of a point, and you differentiate again to find acceleration. But much more than that, the way they teach it is this way. They take a problem, specific mechanism, and they ask a question about it, and then they analyze that. They solve the problem using algebra. They introduce coordinate system, solve the problem completely. And then next section, they solve exactly the same problem using geometry, using vectors, using vector operations, vector analysis. And then next section, they solve exactly the same problem using complex numbers. Next section, they solve exactly the same using, they make students program and solve the problem numerically. And then the next section is discussion of those methods, comparison of methods. And this is the kind of teaching that I think never happens in mathematics, at least the way I am familiar with teaching. It's not about solving problems, and as soon as you solve the problem, you move to the next one. It's about the emphasis on the methods and comparison of the methods. And that's what I like about that approach, and that's what I would like to implement in calculus. And that's what I've been working on, trying to solve problems using different methods and make emphasis on comparison of those methods, not on the problem itself. And then let me talk more about procedures. Well, I began using cloud services, and I use a lot of Google Cloud services like YouTube, Google Documents, Google Forum, Google Mail, of course. And the more I use them, the more I'm convinced that there are things that we can do in a regular class. So it's not about online classes. This is an example I did a few weeks ago in my graduate level class. What I did was I made a document, and let me show you the beginning of this document. So that's what Google allows you. It allows you to go backward in the history and show all the revisions. So I gave a document I shared with all the students in the classroom, and the classroom was in computer classroom. Everybody was in front of a computer. So I shared the document, and they just listed the topics, the terms we learned last week. And I asked them to give definition. And they all began to work simultaneously, typing his or her own definition. And then I was watching this process. And then by the end of the process, we got a file. And the file was growing during those 4 minutes while they were working. And then I asked everybody, all the students, to look at everybody else's definitions and comment and suggest improvements and discuss those concepts. And the whole process of working took like 4 or 5 minutes. And that's something that I can analyze later because I have the whole history of the process. And that's, to me, very much analogous to taking students to Blackboard. Instead of taking one at a time, I can take the whole class to the Blackboard, make everybody work simultaneously, and everybody comment on everybody's work. And if someone wants to comment, he or she can type immediately, right, into the same document, and everybody will see it immediately. So that's the well, one of the uses I plan to well, to implement in the future at larger scale. The other thing is I use Google Documents to, well, I ask students to use those documents to solve problems. So they go to a website where the problems are, they get the problem, they copy-paste the statement of the problem. You don't have to see all the details, but basically there is a statement, and then they have to explain how they solve the problem, and the computation, all the computations necessary are made in Wolfram Alpha. And then what they do is they drag and drop those computations, the results of computation, into the document. And you can see those results here formatted in Wolfram Alpha, and those are the pictures. And now I would like to invite you to imagine how much better this all would become if I use Mathematica Online. Right? It will not be like Google product with pictures brought from Wolfram Alpha. It will be one consistent interface, and everything is naturally there. And well, think about it for the rest of the talk, how everything I'm doing would be much better if I do it. And you see this nice feature of showing me that someone else is also watching that document. Well, it's technically myself, but still. And then I systematically used this process for the last year. Students had to do homeworks this way, creating documents. They had to do tests in computer lab exactly the same way. They had to produce this document with descriptions of how they solve problems. And then they share the document with me. And the beauty of that is not only reduction of paper flow, but it's making the homework process much more efficient. And now we can exchange, and basically that document provides a very good, rich context for communication. Because typically what happens is student goes home and tries a problem and then sends me email, oh, you know, I don't know how to solve problem number 3. Can you help me with that? And I don't know where to start because the complete solution takes about a page. So then I began asking questions, and it's endless communication that is not particularly successful. Now I replace it with a student making a document and working out the solution as far as he can, and then sharing the document with me. And then I go in and help in this rich context already existing of his or her solution. So we communicate over the document, and again, the communication is so effective that whenever student shares the document, I get notification by email. I can immediately go there and I can comment, and that comment, and automatically the student is notified by email. And we can sometimes get together and simultaneously work on that document. So it's very effective and not attached to any deadlines. So, I mean, I have some deadlines for those students who procrastinate to the last minute, but mostly I'm trying to avoid this idea of deadlines and trying to help students real time, well, whenever they have time to work on it. Now, a little bit toward the future is what I'm trying to implement is using Google Hangouts, and in fact trying to make students use those Google Hangouts and record the process of solving the problem. So it is not only the end product, the solution that I get at the end, but I can see the whole process of how the student solved the problem. And let me show you an example and let my student speak for himself. And the interface is very easy. It's a matter of one click.
Over the course of this video, recorded live via Google Hangout, I will be demonstrating how to use Wolfram Alpha and Google Documents to solve an angle bisector problem using vectors. And now that I have a simplified equation that can be used to solve a system of equations in Wolfram Alpha, I will enter my system of equations, which includes the angle equality and the collinear equalities. And Wolfram Alpha yields a tidy conclusion that I will copy and paste into my document. Checking my answers. Everything lines up nicely.
So this way I can see how exactly the student solves, and I can hear the comments, right? And I encourage students to talk out loud what is it that they are doing. And well, of course, a typical question, a typical problem that people ask about all that is, well, how come you have so much time to watch all these videos? And here is my way of handling that. And that's a valid, that's important question. What happens is that technically the student starts this Hangout and in a matter of a couple of clicks begins streaming the whole screen to YouTube, and by the end of the process, when he stops, a file is created on YouTube automatically and saved for the student, and the student can go there, and then what a student can do is, like I did there, he can comment just by typing a text and reflect upon his own process of solving the problem. And I think it's a very important pedagogically to make a student look through his own process and identify what is it that he was doing. And the simplicity of the interface on YouTube allows to type the simple text like 0.44 creating a new Google document. And by the time you click submit the comment, those 044 becomes a link, an active link that starts the video at exactly that time. And this way, a student can describe basically what is it that he or she was doing during the whole solution. And what I would like them to do is, by the end of solution, to provide 2 minutes long, complete, detailed explanation of the solution. And my plan is to primarily watch that part, that they identify there, they provide me with a link, and for me it's a matter of one click. I go to the video, I click there, and I watch their short, nice explanation of the whole solution. And then, if I want to check something else, I can go back and see what the process is, right? But, well, in this case, it is less than 2 minutes explanation of, well, a pretty decent one-page long solution. And then the possible directions to go from here is to think about the group work, because that Google Hangout allows up to 10 people to communicate simultaneously. So the whole process of that communication can be recorded. I haven't tried that yet, but I think that's a great potential to see how students interact and help each other and solve problems together. And another exciting opportunity that I see is the change of the testing environment. Basically, what I would like to have in the future is to step away from this environment when I give a piece of paper to a student with a few problems written, and he or she has to solve all those with a pencil and not having anything. Well, some teachers do open books. Well, I would like to make one step further, open internet environment, when I let a student sit on the computer and I'm telling him the whole internet is available for you. Here's the problem, show me what you can. Right? And then what he or she has to do is start recording and solve the problem and show me what he or she can do about this problem. And of course, well, the assumption is that the whole process is recorded, and of course a student can call a friend and the friend can solve the problem, but then I will see that and 0 will be given. But that opens a lot of opportunities, I think, in the sense that if a student knows how to solve in general, well, he knows the strategy, but he doesn't remember a particular formula, well, he can say so, well, I know how to do it, this is how I'll do it, I just don't remember that formula for the dot product. Let me go to Wikipedia or any other place I know where the formula is. I will go there, I will take that formula, and I will complete a solution. So it will make, well, make it possible for a student to finish the problem, to produce a solution without having particular, well, formulas memorized, or so it is much less dependent on memorization. I'm not saying that memorization is not important, but it's just a way I see we're going to evolve in education. Well, because technology is coming to us, and I just don't believe that engineers these days solve any integrals, take any definite integrals by hand. I'm not an engineer. I don't do it myself. I don't believe they do. I don't believe my students will ever take integrals by hand. So what I'm trying to do is to bring the testing process and therefore the learning process during the course closer to that reality. The reality when everything is available and everything is at the fingertip, right? All the information out there is right there on the screen of your iPhone or whatever smartphone. And then these days, thinking more about the advantage of Mathematica Online and using Wolfram products with these ideas, the great thing to plan to the future is computability of that data that I get from students. So over the time, I can collect those solutions, right? Videos and files, and if those files are in unified Mathematica format with timestamps, with the whole process recorded, well, it will make it possible to programmatically compute and analyze how do students solve the problems, what kind of typical mistakes they do, and suggest and maybe come up with predictive interface for the students. Right? If they get stuck and waste 20 minutes on simple thing, maybe a computer can suggest, well, should we maybe go and learn vector analysis a little bit, right? And look up the dot product formula. So, well, that's much further in the future, but that's why I particularly like to convert the whole process into one standardized Wolfram format, Wolfram Mathematica. And well, I would like to talk about any of that. If you have any ideas, suggestions, I would like to hear that. Thank you.